Physics, impulse momentum. So to describe a little bit about how impulse momentum works, we have an example here of a machine that drives a small ball about 0.05 kilograms, giving the ball an initial horizontal speed of 45 meters per second. What is the average force exerted on the ball if the force is exerted over 2 milliseconds? So what we know from the problem statement is we know the mass of the ball, which is 0.05 kilograms. We know the velocity before it gets driven by the machine, and that's going to be 0 meters per second. And we know the velocity of the ball after it gets thrown by the machine, which is 45 meters per second. And we know the amount of time that it took for the machine to drive the ball, and that's going to be 0.002 seconds, which is 2 milliseconds. What we're looking for is the average force. The average force exerted over this time. So one of the relevant equations we have here is we have the average force, or F average, times your change in time is equal to your impulse. And remember that the impulse is like a moment, or it's like momentum, as the units are going to end up being mass times velocity. So just to understand a little bit about how this is working, note that if you hold impulse constant, an increase in your average force means a decrease in your time that it takes for that to happen. The reverse is of course true. So as a quick example, a car accelerated to a speed of 60 miles per hour can accelerate to a speed of 60 miles per hour. It can get to this speed in 30 seconds, but of course sometimes you don't want it to take 30 seconds to get to 60 miles an hour. So you press down on the gas a little bit and you get there faster. Or if you press down a lot, you can get there in 5 seconds. And to do this, that takes more force. So to decrease the time it takes to reach that 60 miles an hour, you need more force over a shorter time. So, keeping that in mind as we do that with this problem, remember that the impulse can be replaced with a change in moments. So we're going to actually go ahead and do that. We're going to say F average delta t is equal to not just impulse, but this time we're going to say mass times V2 minus mass times V1. And basically what this is stating is that it's a change in your initial momentum and your final momentum. Then we can actually go ahead and pull out the masses. We can factor that out, and so that'll be mass times V2 minus V1. And then we can go ahead and combine some stuff down and solve for F average, and so you get F average is equal to M times V2 minus V1 all divided by delta t. And the delta t, you can actually, if you wanted to, you could sub that out for T2 and T1, or you can just use the delta t that's given in the knowns above. And so for this, we can go ahead and solve for the F average is equal to mass, so 0.05 kilograms, times V2, which is 45 meters per second, minus the V1, which is 0 meters per second, all divided by delta t, which is 0.002 seconds. When you solve this out, you get F average is equal to 1,125 newtons.